available to you, send the frame. The moment the channel is available to you, send the frame and continuously sense it. Okay, so for the successful or not successful transmission. So the moment, if suppose any time if you are observing that okay, the collision if happened, it is going to generate some noise. Okay, based on that you are going to detect. Okay, so then you are going to detect it as a collision. If suppose there is no collision, then what happened? Your transmission got succeeded. If any collision is the purpose of jamming signal. So, dear friends, please try to understand the intention behind the jamming signal is nothing but you need to inform all the stations who are accessing for this particular thing about this particular collision, so that they need not to send the data again. Okay, they should sense that okay, there is some collision was occurred, then immediately we need to wait for some time. So now that is nothing but increment the backup time. So please try to remember this backup time. Already I have told that the exponential backup time. Okay, see the always I have told that here we are going to use binary exponential backup time. Binary exponential backup. So this binary exponential backup we are going to use for the increment of backup. Okay. So now once if that particular backup, when we are creating it and then we are coming back to that, if the backup time, okay, number of times, that is nothing but, so here if suppose what backup time is going to talk about, if suppose first time if you have waited for 2, next time it should be doubled. Okay, that is nothing but 4. So next time you need to wait for more than 8. Next time like that. So but ultimately what is going to be happen, you have assigned the k as 0, then how many times you need to do this particular thing? How many times if the collision is coming, that then you need to retransmit. So for that particular purpose, what you are going to do in the sense, this k you are going to increment over here by using k is k plus plus. So always you are going to increment the k. Now here what you are going to do, until and unless if your k is greater than 15. Okay, if your k is greater than 15, what you can do, abort. Completely you are going to cancel that particular transmission. Otherwise what we are going to do, we will increment it. Now in detailed when you are going to look at, you can have a look at over here whatever I have explained. So now here you see you have assigned the set to backup is k is 0. Then you are using one of the persistent method, one persistent, non-persistent, and p persistent. Any method you are going to use under the CSMA, and then you are, if suppose if everything is fine, you are transmitting it. And if you are transmitting and then you are looking at if collision is not detected, then success. If it is detected, send a jamming signal. Send a jamming signal and then increment the backup time. K is k plus plus. And here if you need to use up to k is greater than k max is 15. So if it is k max is 15, close it. Otherwise use the random time and then this random time always it should be based on your binary exponential backup. Okay, this wait backup time, this time has to be calculated based on binary exponential backup. Okay, so now fine. So we have discussed CSMA by CD, but the point is still there is a possibility of the collision. Okay, there is a possibility of some collision, because now we need to discuss about the collision free. We need to discuss about the collision free. Now here when we will come back to very interesting feature. Okay, see, is it viewable to everyone? Is it viewable? I'm asking everyone, is it viewable?
Yes, sir.
Thank you. Very important thing which you need to understand, because I'm going to explain then our next protocol in the collision free protocols is the limited contention protocol. Okay, so for that particular thing only I'm explaining you from the most important learned yesterday. So we are coming to that. See, in the CSMA by CD collision detection, it is going to work like that. It is going to detect the collision and based on that it is going to happen. But I would like to create a mechanism where I don't want to get collisions at all. Okay. Always, I don't want the collision. We don't want, okay. Anybody wants collision? We don't want collision. Okay. But here in this case, what we are telling that we are doing it, but the collision is occurring it. The moment if the collision is happening, then I need to transmit. But why I need to wait for the collision? I don't want the collision. I don't want the collision. So for that particular thing, what I should do, I need to use the collision avoidance. I need to avoid the collision. So how to avoid the collision? Now here, if you are going to look at that, one important aspect of, now here, if you look at that, in the CSMA by CD model, what we are going to do? We are altering that, consisting of altering contention and transmission periods. Okay, with ideal periods occurring when all stations are quit. See, the moment if suppose you are going to send a jamming signal, what is going to be happen? So immediately you are doing it. But in the CSMA by CD, what we said, the moment if anybody have censored the channel, immediately transmit it. Immediately they can transmit it. But instead of that, what I am going to tell in the sense, if at the time 0, if somebody is sensing it, I am keeping some contention period. So during this contention period, no one is supposed to send any data. Now here you can have a look at that. Okay, see, look at the contention algorithm. What is this contention algorithm? See, here at time t0, if two stations both begin transmitting at the same time at time t0, both were censored the channel ideal. If both are sending, what is going to be happen? Definitely the collision will occur. According to our discussion, what is the meaning of the collision free protocols? So I need to see that the multiple nodes should be allowed to access the channel, but we should not get any collision. But here in this case, what happened at T0, if two stations were sensing the channel, two stations was censored the channel as ideal, then immediately both were sending the frames. But how they are going to come to know that whether they are collide or not? Because both have censored the channel as ideal. So now here the answer is very different, because as I told to you that here, if suppose A is sending, the frame, okay, so when the frame is over here, B never sends the channel as busy because it is not crossed the B. The moment if that particular frame is crossing this B, then only the B will understand that the channel is busy. Like that, so when it will comes to the C, okay, then C will understand. Then when it will comes to over here, then D will understand. So in a quite simple factor, what I said, if this is a cable, if I'm going to say that, if this is a cable length, if I'm going to say this is the cable, okay. So what is the maximum size of your cable? Okay, now here if suppose if I am going to talk about my maximum cable size is something 4 meters, okay, 4 meters, okay, or whatever the size of that particular cable. Now if my packet is transmitting at time 0 over here, the moment if my packet is coming to end, then I can say that all stations can sense the channel as busy now. But the point what is happening in the sense, the frame moving from here to here, okay, before this, if the C is sensing the channel, then always C will sense the channel as ideal. What it will do? It will sense the channel as ideal, and for that particular ideal, what is going to be happen? It will send the frame. Now what is going to be happen after traveling for some period time, then both are going to get collide. Now I don't want to do that, so I don't want this collision. So now here, dear friends, here contention algorithm, here if you are going to look at that, the minimum time to detect the collision is just the time take it the time it takes the signal to propagate from one station to other. But what exactly the worst case what we are going to talk about? Okay, now here ultimately what we are going to talk about, see, based on the information, you might think that a station that has not heard a collision for a time equal to the full cable propagation time after starting a transmission can be sure it has seized the cable. Now, the ultimately the number of stations. See, we mean that all other stations know it is transmitting and will not interfere when you are using this particular size, complete size, when you are going to use. But this may not be correct, this may not be correct, I cannot take it into guarantee, because why I need to wait until that particular time? So every station is going to send that. So in the worst case scenario we are going to look at, in the worst case scenario what is going to be happen? So now here we are going to use the slots. Okay, now here in the worst case what we are going to do in the sense, time for a signal to propagate between the two farthest stations, be T if you are going to take, and at T0, one station begins the transmitting, that is nothing but T0 plus T, okay, which you are going to take it. But ultimately what is going to be happen in the sense, now in the worst case, a station cannot be sure that it has seized the channel until it has transmitted 2T without hearing the collision. We are not going to get the guaranteed. That is the reason. In the contention, what we are going to do in the sense, we will create a slotted aloha. We will add the slotted aloha. We will use that. See, CSMA BCD contention as a slotted aloha system with a slot width of 2T, which we are going to discuss over here. Okay, so now that much time you are going to wait so that you can understand. Okay, so now that was the reason. Now in the collision free protocol, what we are going to do in the sense, in the limited contention protocol, okay, in the limited contention protocol, we are going to see, in the limited contention protocol, what we are going to do in the sense, what we are going to do, whenever we are using the CSMA, we are going to use the CSMA. Okay, under the CSMA, one of the mechanism which we are going to use, whenever it is found ideal, immediately it is not going to send, it is going to wait for some random time called interframe sequence, interframe sequence, so IFS. And then after waiting for some time, then again it is going to use the size binary exponential, and again it is going to give a contention window, and during after this contention window only we are going to send the frame, and this is going to be waited for some time, so that I am not going to get the collision over here. So in the previous case what we discussed, when they are sending over here, when they are ideal, when they are sensing it as ideal, immediately if they are sending it, two stations were sending it, there may be a possibility of getting collision again. So if I want to avoid the collision, if I want to avoid the collision, what I should do, I need to wait for some interframe sequence, interframe sequence. Okay, so now here, okay, so now here if you are going to look at that, here the ideal is there. So but when they are sensing ideal, so again if they are sending it, there may be a chance of getting collision. So now that was the reason what we are going to do, we will use the CSMA by CA, carrier sense multiple access with a collision avoidance. In the collision avoidance, what we are going to talk about, okay, interframe space, IFS. Okay, so once if the channel is ideal, you need not to send immediately. Okay, so we need to avoid collision on wireless network. This is exclusively on wireless network. CSMA by CD is on wired, CSMA by CA is on wireless. Okay, this also very important point, you can note it down. So now in that particular situation, this interframe space we are going to use it, and after that again we are going to give a contention window, and then based upon that contention window, now here we are going to do that. Okay, so here this IFS can also be used to define the priority of a station or a frame, so that who should access that particular thing. And if the station finds the channel is busy, it does not restart the timer of the contention window, and it stops the timer and restart it when the channel become ideal. So like that, the contention window is going to be started. The contention window is going to be started, and if still in the after the contention window also, if it is going to sense the channel as ideal, then immediately it is going to transmit. It is going to transmit it. So how it is going to be happen? Now here, if you are going to look at, okay, so here if you are going to look at, so now here the K is 0 you are assigned, and if ideal channel, wait for IFS time and then check, still ideal, come back. Okay, go forward. Okay, and then you are going to create a contention window of size 2 to the power of K minus 1. Okay, and then once if R slots, okay, whatever the things were there, that many number of slots you are going to wait. After waiting also, see, after each slot, if ideal continues, if ideal and continue, if busy, what you need to do, halt and continue when ideal. So now this is what exactly your CSMA by CA. So this is always you need to understand, sorry, this you need to understand, you need to keep it in your mind. This particular logic we are going to use for wireless. In the wireless only we are going to use this mechanism. So now you will ask that, sir, what is the method we are going to use for the wired? Okay, wired collision free protocols which we are going to use. Okay, so now in the collision free protocols, already what we discussed, binary bitmap protocol and binary countdown. Okay, so under the collision free protocols, for how we are going to avoid the collisions for CSMA by CD, by using the bitmap protocol, by using binary countdown, by using limited contention protocols, and by using adaptive tree walk protocol. So bitmap protocol, which we have already discussed, that okay, it is going to send a window of how many number of things were there, and whoever wants to send, they need to give their bit. Okay, one bit it is going to keep it, so only that particular thing is going to be allowed. Then again you are going to recirculate the bit window, and so bitmap protocol, and then whoever the station wants to send, it will give that. So next case 1467, so 1467 will be given access. Okay, so like that it is going to be happen in the bitmap protocol. In the binary countdown, what we said, in the binary countdown, what is going to be happen? So we are going to say that, okay, so every station is going to announce their address. Every station is going to announce their address. Okay, so now what we are going to do here, we are going to take the first bits. So 0, 1, 1, 1. Then you are going to XOR it. So now the result of R, when you are using 0 R, okay, that, so what is the value you are going to get? 1. When it is 1 is there, what you are going to happen? So immediately you are going to verify. So now here what is going to happen? The first bit is 0. So here the result is 1. So this first station is going to understand that there are some other stations who are competing, okay, with a highest priority. So that was the reason what is going to be happen? The station gives up. This station gives up. Then next, so here the first bit 1 1 1, all the three bits are 1. So now who should get it? Then we are going for the second bit. Okay, so in the second bit, now what is going to be happen? Now this is 0, this is 1, this is 0. Now when you are going to R8, then again you are going to have 1. Now by looking at this one, what is going to be happen? Now this station 2 and station 4 will give up. Then so who is going to get? The station will proceed. Now that is nothing but the third station with this address is going to proceed. Now the disadvantage of this particular binary countdown is what? Always the lowest priority is supposed to wait until it is going to get turned. But the problem is, what is going to be happen? Always the highest priority is already there. Always the highest priority is always there. So now that was the reason. So there is a disadvantage. So in the conclusion, we are going to discuss about those particular things. But now I hope you have understood the binary countdown. Then when it will comes to the limited contention protocol. So in the limited contention protocol, now here if you look at that collision based protocols, when you are going to look at that pure aloha or slotted aloha or CSMA by CD are good when the network load is very low. But we need to compensate whenever the network load is high in that particular situation. Okay, so collision free protocols like your bitmap protocol and binary countdown are good when load is high. Okay, easily you can check. Okay, so you can avoid the collision. But how we are going to overcome this particular thing? Pure aloha or slotted aloha and CSMA by CD are having their advantages. But by taking their advantages into that and improving their performance when the network load is high. Okay, so that was the reason we are going to combine their advantages, and here we are going to say that behave like a aloha scheme under light load and behave like a bitmap scheme under the heavy load, so that I should not get the collision. So that is what we are going to talk about, the limited contention protocol. So in the limited contention protocol, as I mentioned to you that, so here in the limited contentions protocol, we are going to calculate that and we will use the slotted aloha. We will use the slotted aloha and then we will do that. See here, that is what exactly I am going to mention, that we will use that. Okay, so slotted aloha scheme to increase the performance of this contention and how best we can go for that. This is limited contention protocol. And another final collision free protocol is adaptive tree protocol, and which is a very easiest way to understand the adaptive tree protocol. Now here adaptive tree protocol, now here what you are going to do, initially whenever all the users are there in the network, okay, you are going to do the things. See, you need to do what you need to do, partition that. Okay, so here okay. Now what you need to do in a sense, you need to partition the particular nodes. Okay, see here, this is what exactly n by 2 and 1 from the rest. So now here simple way I will explain. You see, initially all these leaf nodes can compete to the root node and they can access it. Okay, but if they are able to access it, it is okay. But if there is any problem, then what you need to do, you need to divide. Okay, you need to divide and only these nodes can be given a chance. Okay, let us have a look at the example. Okay. How we are going to do this? Treat every station as a leaf of a binary tree. First slot, after successful transmission, all stations can try to get the slot. Everyone can try for the slot under the root node. Under the root node, that is nothing but if this is a 0, under the root node, what are the things for there? Here, if you look at that A, B, C, D, E, F, G, H, all the nodes can compete. Okay. If no conflict, If there is no conflict, only one user wants to access it, fine, allow it. If not, now your adaptive tree walk is going to come into the picture. In the adaptive tree walk, what we are going to do? In case of conflict, only nodes under the subtree get to try for the next one. Based on what? DFS, depth first search algorithm, which you have learned in your data structures. Based on that. Now, here, if this is the adaptive tree protocol, now how it is going to work? Okay, example you can have a look at. In the example, now when you are going to look at, now, okay, let me minimize it. Now, here you can have a look at. Okay, I can increase a little more size. Now, here, if you are going to look at that, what is happening? So, now A, B, C, D, E, F, G, H. Now, imagine here, competition, if you are going to look at the star indicates that these are the users wants to access it. Okay. Now, in the slot 0, C, E, F, H, all nodes under node 0 can try, which are going to send. Now, what has happened? Conflict erased. Conflict erased. How many wants to access? 4. When the conflict erased, now you divide. You divide, and now you need to give a chance to the subtree. Now, in the slot 1, what is going to be happen? All nodes under node 1 can try. All nodes under node 1 can try. So under node 1, now A, B, C, D. Who wants to access? Only C. Any conflict? No. So C sends. All these are under wait. Now only this particular part we are going to use. Now after that, now when it will comes to this slot 2, now what happened? Node under 2. Now who are competing? EFH conflict. When EFH is conflict, then again the subtree under 2. Who is that? 5. So in the 5, now slot 3, all nodes under 5. So again conflict arises. So slot 4. So E will get a chance and E will send. Then slot 5, F will send. Then when it will comes to the slot 6, H will send. So this is what we are going to talk about, adaptive tree walk protocol. Everybody have understood this? Everybody have understood this? Post in the chat. Collision free protocols. Collision free protocol for wired network is with bitmap protocol, binary countdown, limited contention protocol, the adaptive tree walk protocol. And when it will comes to that wireless, CSMA by CA we are going to use. Why we are going to use the CSMA by CA? I will tell you that. See, there is a contention. See, pure Aloha, slotted Aloha, CSMA and CSMA by CD are contention based protocol. What is the meaning of contention based protocol? Try, if collide, retry. No guarantee of performance, and what happens if the network load is high? That is the reason we are going to call them as contention based protocol. So we need to overcome that. That was the reason we will go for the, we have gone to the collision free protocol. Okay, so I requested everyone to post in the chat whether everybody have understood what is bitmap, what is binary countdown, what is limited contention, what is adaptive tree protocol. Please be fast. Srikar. Srikar.
Yes, sir.
What happened?
Yes, sir.
I understood there is a delay. If anybody is having any doubt. Anyone can tell me what is the adaptive tree protocol, how it is going to work? Srikar, can you explain adaptive tree protocol?
Yes, sir.
Yeah.
I mean, Initially, different nodes are written in the form of a tree
Binary tree.
format,
Binary tree.
sir, binary tree format. Then the internal nodes will be marked with the numbers,
Hmm.
and the tree always starts with a 0.
Yes, root node.
Root node always starts with a 0, and different nodes are written according to the network's
It is
protocols,
not
sir.
like that, Nana. See, the simple way, all the nodes are going to be given the first priority. In the first go, everyone can access, everyone can compete. See, that is what I mentioned here, the points. You see, what happened? Treat every station as the leaf of the binary node. Everyone can access it. So if there is no conflict, means only one particular node, if it is competing, then there is no problem. But if multiple number of nodes, as I have shown the example, now here, if suppose if you look at that C, E, F, G, F, H, when 4 wants to access, what happened? Conflict. Okay. So when the conflict is there, what I told you that divide. What I told that you need to divide, and then so here we are going to have next you are going to give the two node. Under the two node, if suppose only C would like to access it, then you can give it. Now next you will come to the 3. In the 3, now who are there? This E, F, H wants to access. Now what happened? Now again conflict. When conflict is there, you will come to the 6. In the 6, now what happened? E and F. So first you will give the chance to E, then you will give the chance to F, then it will comes to the 7. In the 7, who is there? No competition. G is not competing, so only H. So you are going to give it to the H. Now this is how adaptive tree protocol is going to work. Understood now? Understood?
Yes, sir.
Okay. So the next important point, okay, the collision free protocols we have completed. Then we are going to have controlled access. What we are going to have? Controlled access protocols. So when you are going to look at the controlled access protocols, we are going to have reservation, we are going to have polling, we are going to have token passing. Try to understand what is reservation. See, these are not mentioned in your that, but these methods are going to be used for our things. So this is what I have already explained, but why I am telling in the sense to understand what is this reservation. Bitmap protocol, which we discussed that. You see, you are going to send the things initially by keeping all 0, and whoever wants to register. See here, if suppose you are going to look at that 1, 3, 4 are marked 1, so you are going to send. You are going to allow first station 1 to send, the station 3 to send, station 4 to send. Then again you are going to give a window. Now only station 1 you are giving to the station 1. Okay, and then you are going to have the zeros. Now whoever wants first, they need to fill that. This is reservation, like in the train how we are going to reserve the seats, like that. Okay, this is what exactly we are going to do that. Second one is the polling. What is the second one? Polling. See, in the polling, now this is what exactly you need to understand. In a client and server, what is going to be happen when a primary wants to send? Primary is going to use what? Primary is going to issue select. If primary wants to send to B, primary will issue a select, and then B has to acknowledge. And once if the B is acknowledged, the primary is going to send the data and B is going to acknowledge it. Okay. So now the ultimate important point is, so this is, sir, you are mentioning that when primary wants to send the data, but what is going to be happen, sir, when secondary station A or B wants to send the data to primary? So in that case, what is going to be happening is nothing but always a primary station is going to send a pole to the stations. See, it is going to send the pole to A, it is going to send the pole to B. Now, here A is not having any data to send to the primary station, so it is going to respond with a negative acknowledgement. Okay, it is not having any data to send. But whereas if B is having a data to send, what it is going to do? It is going to send the data. If you don't have any data to send, you can say negative. But whenever secondary wants to send to the data, so what it should do? It should wait for the poll. Now that is what exactly we are going to call it as a polling. Now everybody have understood the polling? Then next one is the token passing. In the token passing, what we said, everyone is going to use the token. Now this token is going to be rotated in the ring fashion, okay. So now initially station 1 is received the token. Now whenever the token received by the one station, now the station 1 can transmit it. Now if station 1 does not have anything to send, it can transfer the token to the station 2. Now whenever the station 2 wants to send the data, even if it is having the data to send, it should wait for the token. The moment if the station 2 is receiving the token, then only it is allowed to send the data. Otherwise, no. Now, sir, if this is coming to this, and if station 2 does not have any data to send also, if it is not passing the token, what is going to be happen, sir? No problem. So we are going to keep some time. Within that time only, this token will be available over here. After the time will be out, and then the token will be automatically passed to the station 3. Now the station 3, whenever it is going to receive the token. So ultimately what we are going to say in the sense, whoever is having the token, only they need to transfer the data. Only they need to use the channel. So with this, what is happening? I am best utilizing the channel because no other person can transmit it. I cannot expect any collision. Now this is what exactly we are going to talk about, the controlled access. Under the controlled access, we are going to have the 3 mechanisms: reservation, polling, and token passing, okay, which are going to act as a collision free also. Okay, so now then we are going to have a channelization. Under the channelization, we have already discussed that FDM and TDM, okay, and we are going to have a CDMA also, but that is not there into your syllabus. Okay, no, don't worry. Then when we are going to look at one of the very important, that CSMA by collision avoidance. Okay. Now here, very interestingly, you need to understand. Okay. See, CSMA by CD would break down in wireless network. You have not questioned me when I have explained CSMA by CD for wired, and it will not be for wireless. Okay, and for wireless we are going to use CSMA by CA. No one has asked the question, sir, why? Why this CSMA by CD will not work? Now please try to remember, because of hidden node and exposed node problems. Everyone please note down, CSMA by CD will break down in the wireless network because of hidden node and exposed nodes problems. What is a hidden node problem? Have a look at. If you are going to take a wireless network, okay, in the wireless network, when you are going to look at, okay, you can have a look at in the wireless network like this, okay, A, B, C, D. And here you are drawing the Venn diagram. See, this is the range of A, this is the range of C, okay, and here like that. Now here, if you are going to look at, it is possible that A is sending a message to B, but C is out of the range, and hence while listening on the network, it will find that network to be free and might try to send packets to B at the same time as A. So there will be a collision at B. The problem can be looked upon as if A and C are hidden from each other. Hence, it is called hidden node problem. Dear friends, if you are going to understand over here, See the hidden node problem. What happened? When A is sending to B, when C is sending to B, now what is happening? Both are listening that the channel is free because within the A's range, C is not there. Within the C's range, A is not there. So what is happening? A and C are not visible to each other. Now here you can have a look at what we are going to talk about. The problem can be looked upon as if A and C are hidden from each other. This is known as hidden node problem. Understood? Trigger?
Yes, sir.
Understood? Hidden node problem.
Yes, sir.
See, whenever this particular thing is there in the wireless, what is going to have? We are going to have a range of that particular node. So, wireless node, it is going to have no, like your router is going to have 100-meter range or like that. So now this is the A's range and this is the C's range. Now A is out of C's range, C is out of A's range, but when both were trying to send it to B, now the problem is going to be happen. The collision may occur. Now that was the reason we are going to call it as a hidden node problem. Then another one, when we are going to look at that exposed node. What is the another problem? Exposed node problem. Now in the exposed node problem, what is going to be happen? You can have a look at. In the exposed node problem, see, if C is transmitting a message to D and B, okay, sorry, if C is transmitting a message to D and B wants to transmit a message to A, okay, B will find the network to be busy as B hears C is transmitting, okay, and even if B would have transmitted to A, it would not have been a problem at A or D, but what is going to be happen? CSMA by CD would not allow it to transmit a message to A, while the two transmission could have gone in parallel. Now here, if you are going to look at what is happening, when B is sending that, okay, so B is going to hear that, okay, this channel is busy. But actually, if you are going to look at that, B is in the area of this particular region, in the B area, A is there, in the B range. There is no problem, there is no defect, or there is no collision will occur when it will allow. But when I am going to use the CSMA by CD, what is going to be happen due to this exposed node problem? Okay, so B is available in the C's range, and when C is sending to D, B is thinking that this is busy. So this range is busy, so it will not allow B to send it to A, but it can send it. Now, due to this problem, we are going to use the CSMA by CA. Now you understood? In the CSMA by CA, what we are going to do, we will send a request to send and clear to send. Okay, so that is what exactly we are going to use. So in the CSMA by CA, we are going to use the RTS and CTS. Okay, so initially, see, consider the figure above. Suppose A wants to send a packet to B, then it will first send a small packet to B called RTS. In response, B sends a small packet to A called clear to send, CTS. Only after A receives a CTS, it can transmit the actual data. This is what exactly something like I have explained polling. Okay, RTS and CTS, which we are going to use over here. So now this is how it is going to work for this particular thing. Okay, so I hope everybody have understood this particular thing. So wireless network data and how it is going to be happening in the wireless CSMA by CSMA by CA, and then what is the hidden node problem, what is the exposed node problem, and multiple access channel protocols like random access protocols, static channel allocation, dynamic channel allocation, reservation protocol, polling, token ring, Aloha, CSMA, CSMA by CD, CSMA by CA. Everybody have understood? Okay.
Yes,
So
sir.
any doubts? Any doubts? Okay. So we will stop the session over here. So with this, the second unit was completed. So packet switching and circuit switching already we have a discussion.